Introduction, the rock cycle. How does the rock cycle model the movement of Earth's materials and energy? How does the rock cycle model the movement of Earth's materials and energy? So let's look at the vocabulary first. Igneous rock, sedimentary rock, metamorphic rock, crystal, mineral, intrusive rock, extrusive rock, and rock cycle. The introduction. If you have ever taken it home with you in your shoes or beach bag, you know that sand is a great traveler. Look at the sand in this photo taken in Africa's Sahara Desert. In the background is a rock formation, sometimes called the Rock Castle. How long do you think the Rock Castle has existed? Has it always looked this way? Note that the rock formation is surrounded by sand dunes. What is this sand made of, and how did it get there? Look closely at the photo for clues. You will see ripples in the surface of the dunes. What caused these ripples to form? Now compare the color of the sand to the color of the rock formation behind it. What might this tell you about the origin of the sand? And origin means where it came from. Where did it originate? Where was it created at? What do you think will happen to the rock castle over time? What do you think will happen to the sand? Right here. You have learned about how energy moves matter in Earth's systems. In this lesson, you will continue to explore how energy causes changes within the geosphere. You will learn what rocks are made of, how they form, and the processes by which rock change from one type to another. Finally, you will observe the methods and tools scientists use to study rocks for the clues they hold to Earth's history. Page 58, Section 1, Observing Rocks. Suppose you're on a field trip to study these three rock formations in the southwestern United States. Southwestern United States would be states like New Mexico and Arizona and maybe parts of California. The purpose of your trip is to look for clues to how rocks form. What could you learn about the rocks at these locations? Well, you could learn about their composition and texture. Scientists use two characteristics to help them understand how rocks form: composition and texture. Now, a rock's composition is what it is made of. Different rocks are made of different materials. A rock's texture is the way it looks and feels. Texture is determined by the size, shape, and arrangement of the particles or grains that make up the rock. Fine-grained rocks are made up of small particles and feel smooth. Coarse-grained rocks are made up of large particles and feel rough or bumpy. Now, there's three kinds of rocks. Your first stop is at the Enchanted Rock in Texas. The rock, granite, is made up of large pink, white, gray, and black grains. Rocks that form from the cooling and solidification of magma on or below Earth's surface is called igneous rock. And the picture is in the upper right-hand corner. Next, you visit the Navajo sandstone in Arizona. That's the picture there in the middle. The rock has fine grain layers. Sandstone forms when sediment, small pieces of weathered rock, is deposited in layers. Rocks that forms from the deposition of dissolved materials called rock fragments or the remains of organism is called sedimentary rock. So let's back up. Igneous rocks are made from when magma or lava solidifies. Sedimentary rock is made when tiny rocks get stuck together. And last, you will visit Antelope Island State Park in Utah. Here, the rocks are coarse-grained with wavy layers. Heat and pressure inside Earth can change rock. Rock that changed in composition or texture by heat and pressure is called metamorphic rock. So going back again, three kinds of rock. Igneous rock, that's born of fire and molten lava or magma that solidifies. sedimentary rock, which is made of all different kind of tiny pieces of rock and sand. And then finally, metamorphic rock is you take any other kind of rock and you squeeze it and you put it under a lot of heat and pressure and you get metamorphic rock.